Assalamualaikum and good evening. My name is Muhammad Abdul Hakimi Memo Azmi. We are from Section 2, Group 7. Our group consists of Haris Aiman, Muhammad Adri, me, Afiq Imran, Nurul Aqwa and Nur Hafiza. So today we will be presenting our project Fault Detection and Protection SIM for a three-phase distribution network using a Simulink.
Hi, Assalamualaikum. Now I would like to talk about the introduction about our project. Implementing a robust protection plan in a three-phase electrical distribution network is crucial to ensuring system safety, reliability, and continuous operation. Faults such as short circuits, phase imbalance, and ground faults is often caused by weather, equipment failure, or external interference. It can lead to serious consequences like equipment damage, blackout, and safety hazards. Protection systems are designed to quickly detect and isolate faults, minimizing impact and preserving service to unaffected areas. As modern power systems become more complex due to smart grid, renewable energy, and distributed generation, protection mechanism must adapt to handle variables, load, and bidirectional power flows. Advanced tools like digital relays and MATLAB simulation are essential for designing, testing, and refining this system before deployment. Effective protection ensures not only technical reliability but also compliance with safety standards, economic efficiency, and regulatory requirements. It also prevents disruption to critical service and improve overall system resilience and customer satisfaction. For our project, there is three objectives in three-phase distribution network, which is we want to simulate various typical fault condition in a balanced three-phase distribution, to detect and sense faults using appropriate and reliable monitoring methods in a distribution system. And the last one is to design and implement effective protection strategies, ensure the remaining section continues to operate without any loss in capacity. Thank you.
Assalamualaikum. My name is Haris Salman bin Suhaimi, and for my part, which is methodology. And for this part, the flowchart describes a step-by-step process for simulating fault detection and protection in a three-phase distribution network using Simulink. And from this flowchart, it starts with the building the system model, and after that we defining the parameter and applying a fault scenario. And if the fault current is detected, the response is monitored. Then an overcurrent relay is implemented by setting its pickup current and time delay. Next, the simulation is rerun to check if the relay operate correctly. If not, adjustments are made until it works. And next, the system post-fault behavior is then evaluated. If recovery is acceptable, the final results such as fault current, relay time, and system performance are recorded, followed by a conclusion and discussion of the finding. That's all of the summary from this flowchart. Thank you. That's all from me.
Hello and Assalamualaikum. My name is Safi Ibrahim B. Ismadi. My matrix number is DE220111. I am a representative from Group 7, which consists of the four peoples, which is Haris Aiman, Adri Hakimi, Nurul Aqwa Nabila, and Nur Hafiza. For our group project, we need to simulate distribution system type and balance three-phase fault type on Simulink MATLAB. As we can see here, this is the distribution system simulation that consists three-phase source, three-phase VI measurement, three-phase series RAC load, which is the consumer, and also we put the scope to see the waveform of the voltage and the current. I also set up the stop time, which is the 0.3 seconds, and then we need to run the simulations to see the waveform of the voltage and the current. As we can see here, the voltage waveform, we can see for each phase have a good sine wave, While the current waveform, we also can see the good sine wave, good waveform for each phase of the current waveform. For the next one is, we need to simulate the balance fault condition, which we put the three-phase fault at the between of the three-phase VI measurement and the three-phase series RLC loads. As we can see here, we set the fault between the phase A, phase B, and the phase C. And then we set the three-phase source phase-to-phase voltage, which is 11 kilovolts at the frequency the 50 Hz. And the three-phase series RLC load, we also set the same, which is 11 kilovolts and the 50 Hz. And for the step time, we inject the 0 at the 0.2 seconds. And for the simulations, we put the 0.3 seconds. So after we run the simulations, we can see at the voltage waveform and the current waveform occur at the 0.2 seconds. So for the voltage waveform, as we can see here, for each phase, the voltage drop close to the zero at 0.2 seconds at the fault location because it is short to the ground. While the current waveform, we can see the current increase significantly at the 0.2 seconds because it is flow directly from the phase to the ground. The last one is we need to simulate the appropriate rotation strategies for our balance fault conditions. So as we can see here, we have set up the three-phase breaker between the three-phase source and the three-phase series RLC loads, which is the three-phase breaker we put for each phase, phase A, phase B, and phase C. And we also put the relay here at the current waveform scope, and we can see inside the relay we have set up the relay, which the relay can detect the abnormal conditions for like overcurrent, and it trigger the circuit breaker to isolate the fault. So the three-phase fault also we put at the balance three-phase, which is for each phase. We also set up the step here, which is we need to inject the fault at the 0.2 seconds, and we need to run the simulations to see the voltage and the current waveform after we put the three-phase breaker and the relay. So as we can see here, the voltage still drop close to the zero, and the current waveform now at the 0.2 seconds are also close to the zero because we put the relay one. The relay detect the overcurrent and it trigger the circuit breaker to isolate the fault. So to get the normal conditions or the good waveform or the normal waveform, so we suggest to put the three-phase programmable voltage source for each phase. And for the setup, we put the 11 kV on the amplitudes and the 50 Hz on the frequency. And then we need to put for each phase. And then we need to run the simulation to see the result. So as we can see here, the voltage waveform are back to the normal conditions, and also the current waveform also back to the normal conditions. I think that's all from me and my group. Thank you.
The study demonstrated the effective use of the Simulink platform along with Simscape electrical and specialized power system libraries to model and simulate a fault detection and protection strategy for a three-phase distribution network. By simulating various fault types such as line-to-line fault, line-to-ground, line-to-line, and line-to-line ground fault, that the model identified critical points requiring protection and assessed fault severity in terms of power continuity, equipment safety, and system stability. The integration of protective elements like circuit breaker, overcurrent relays, and logical control will be enabled prompt fault isolation and system recovery, minimizing downtime and enhancing safety. Furthermore, the simulation offers a valuable foundation for developing adaptive protection systems and smart grid technologies, underscoring the role of digital tools like MATLAB or Simulink in advancing power system research and education.